Today, we're going to look at a story that is, well, it's a chilling cautionary tale. It's about the raw power of physics, how fragile the human body really is, and the absolutely catastrophic consequences of a single split-second mistake. So to really get what happened here, we have to start with a question, and it's a deeply unsettling one. Just think about it for a moment. What happens to a human body when 9 atmospheres of pressure, that's like being 300 feet underwater, just vanishes in a single second? The answer is violent. It's almost unimaginable. The laws of physics just take over with this horrifying force. We're talking about an event so extreme, it completely redefines our understanding of what a catastrophic death can be. Okay, let's dive into this. A 1-second catastrophe. We're going back to November 5th, 1983, on the Byford Dolphin oil rig, way out in the North Sea. We're here to understand the anatomy of one of the most horrific industrial accidents in history. First things first, to get what happened, you have to understand the world these men were living in. I mean, this wasn't your typical 9 to 5. It was more like living on another planet. They used this technique called saturation diving. Basically, they lived for weeks at a time inside a pressurized habitat. This kept their bodies used to the absolutely crushing pressure of the deep ocean, so they didn't have to decompress every single day. So get this, their entire world was pressurized to 9 atmospheres. That is 9 times the pressure you and I are feeling right now. It's the equivalent of living permanently almost 300 feet underwater. Their bodies were literally saturated with gas under this constant, immense force. Yeah, this was not a normal existence. They lived in these cramped, claustrophobic metal chambers. They weren't even breathing regular air, but a mixture of helium and oxygen called heliox. And a really weird side effect of all that helium, it distorted their vocal cords, making their voices super high-pitched and squeaky. You know, they literally called it the Donald Duck effect. So the fatal procedure. Here's the crazy part. The disaster didn't even happen down in the dark depths of the ocean. Nope. It happened right up on the deck of the rig, during what should have been a completely simple, totally routine transfer. Let's just walk through the final minutes. It's just after 4 in the morning. At 4:01, the bell connects to the chamber. 7 minutes later, at 4:08, the divers inside open the door connecting the two. And then, at 4:13 a.m., a dive tender on the outside, a man named William Crammond, makes a fatal error. He releases the single clamp securing the bell to the chamber. And here is the absolute crucial point. The entire system was still pressurized, 9 atmospheres. The internal door connecting the bell to the chamber, it was still wide open. The only thing holding that immense pressure back from the 1-atmosphere world outside was that single clamp. And it was just released. And this right here, this is the real heart of the problem. You see, it wasn't just one guy making a mistake. It was a mistake that was basically waiting to happen because of a catastrophic design flaw. The whole system relied entirely on a human following procedure correctly every time. Modern systems, they have mechanical interlocks that make it physically impossible to release the clamp if there's a pressure difference. The Byford Dolphin had no such failsafe. Which brings us right back to our opening question. What happens, physically, when that barrier between 9 atmospheres and 1 atmosphere is removed in an instant? Well, let's talk about the physics of obliteration. Let's talk about explosive decompression. So imagine this. The pressure inside the chamber dropped from 9 atmospheres all the way down to 1 in a fraction of a second. The force of that escaping air was just tremendous. It blasted the diving bell clean away and killed the tender, William Crammond, instantly. But for the 4 divers inside, the real horror was just beginning. Explosive decompression is an event so violent it turns the body against itself. All the gases that were compressed and dissolved into the diver's blood and tissues under 9 atmospheres of pressure suddenly had no force holding them in. They expanded instantly and violently. The investigation findings describe a grim reality. The rapid pressure change caused the gases in their blood to come out of solution, essentially boiling their blood from the inside out. The fat in their blood turned to foam. It was an instantaneous, total system failure for the human body. And you can see here, it's not just one thing, but a complete cascade of fatal events. You've got massive internal trauma from the expanding gases, embolisms blocking all blood flow, and then just severe blunt force trauma as the hurricane of escaping air turned equipment into projectiles. For one of the divers, who was standing by the partially open door, the pressure difference was so great he was forced through a crescent-shaped opening just 60 centimeters wide, disintegrating him instantly. The story, as horrific as it is, doesn't just end there. The disaster sent shockwaves through the entire offshore industry. And the crucial question on everyone's mind became, how do we make sure this never, ever happens again? So, who was to blame? The man or the machine? Initially, the company tried to blame the tender who opened the clamp, but he also died in the incident, and investigators knew the answer had to be more complex. Was it really just the fault of one man, or was the machine he was operating fundamentally unsafe? Investigators ultimately identified what's known as a latent failure. The true fault didn't lie with the individual, but with a system that was not designed to be tolerant of inevitable human error. A tired worker, a moment of confusion, these things happen. A safe system has to be designed to account for that. And as a direct result, the Byford Dolphin disaster became a catalyst for massive change. The industry moved and moved fast to mandate the very things that were missing: mechanical interlocks, redundant alarms, automated checks, and standardized training protocols for everyone. Today, you have international organizations like the IMCA and the ADCI, and their whole job is to set and enforce incredibly strict global safety guidelines. They certify the equipment and procedures to make sure a tragedy like this remains firmly in the past. And what you should really take away from this is that modern safety standards aren't just abstract rules in a manual. They are a direct legacy. They were built upon the lessons from the mistakes and tragedies of the past, written in the memory of the 5 men who died on the Byford Dolphin. And this leaves us with a final, pretty provocative thought. The Byford Dolphin accident is a stark reminder that we so often design systems for perfect operation. But the true test of any design, whether it's an oil rig or just an app on your phone, is how it performs when we as humans inevitably make a mistake.